Applying the equations of motion. Problem 2. A wooden block is pushed up a slope with an initial velocity. It slides up the slope to a distance of 5 meters, stops for an instant, and then slides down. The slope is smooth and friction does not act on the block. After 4 seconds, it reaches the same point from which it was pushed upwards. Calculate the initial velocity of the block. Also, calculate the velocity of the block when it reaches the point from which it was pushed. What is the magnitude of the acceleration? What is the time taken to slide up to the highest position? Solution. Let us observe the motion of the block closely. We see that the block starts with an initial velocity, slows down and reaches the highest point on the slope, where its velocity is 0. Then, it reverses the direction and slows down, speeding up continuously along the way. The block is in an accelerated motion throughout its journey to the top and its return. We assume that this acceleration is uniform. Since the slope is smooth, there is no frictional force that opposes the motion of the block in its entire journey. If the slope is not smooth, the acceleration will not be constant, and this method of solving the problem cannot be used. The acceleration is directed towards the bottom of the incline, since the block is constantly pulled down in that direction. The block reaches the highest point, which is at a distance of 5 meters from the point where it was pushed up. We first draw a rough sketch to illustrate the problem. As we are dealing with vectors, like velocity and acceleration, we choose a direction as positive. Let this be the direction to the top. We mark the variables on the sketch. The acceleration is constant and is directed downwards. The initial velocity is directed upwards, whereas the final velocity, that is, the velocity when the block reaches the same point from which it was pushed up, is directed downwards. Next, we note the given data and variables that we are required to find. The time interval for the motion from the start to the end is 4 seconds. The displacement from the initial point to the highest point is plus 5 meters, that is, 5 meters towards the top of the incline. We are required to find the initial and the final velocity and the acceleration. It is important to note here that the block is under constant acceleration. Hence, it will have the same magnitude of velocity at the final position as the magnitude of the velocity at the initial position, since the two positions are identical. Therefore, v final equals negative v initial, since they have the same magnitude but are oppositely directed. Also, the time that it will take for the block to slide from the initial position to the top is the same as the time that it will take for the block to slide down from the highest point to the final position. This is a very important idea, known as time symmetry. We use the equation of motion that relates the initial and final velocity. V final equals V initial plus A delta t. Here, delta t is the total time interval from the initial position to the final position, that is, delta t total. Combining the two, we get, rearranging the terms, negative 2v initial equals A delta t total. Substituting the value of delta t total, v initial equals negative 2a. Note here that we have retained the acceleration as a, even though it is directed towards the bottom of the incline. The final solution will give us the direction of the acceleration. Now, we consider the motion of the block from the initial position to the highest point. The initial velocity is the same as the initial velocity for the entire motion, and the final velocity is 0 at this point. The time interval for this motion is 2 seconds, due to time symmetry. We are also given the displacement from the initial position to the top, which is 5 meters. We use the equation of motion that relates the initial velocity, the final velocity, and the displacement. V final square equals V initial square plus 2a delta x. Substituting the values, we get V initial square equals negative 10a. Combining equations 3 and 4, we get negative 2a the whole square equals negative 10a. 4a square equals negative 10a. Since a is not 0, a equals negative 10 over 4 equals negative 2,5 meters per second square. Hence the acceleration is 2,5 meters per second square towards the bottom of the incline. Substituting this in equation 3, we get v initial equals 5 meters per second. The initial velocity is 5 meters per second towards the top of the incline. Substituting this in equation 1, we get V final equals minus V initial equals negative 5 meters per second. The final velocity is 5 meters per second towards the bottom of the incline.
Starting to feel it? Now go master it with Maskitv.